Okay, today we will be doing topic 16, lesson 4, which is experimental probability of compound events. That would be more than one event happening at the same time or at different times. We have dependent events, which is one result is reliant on what happens in the first event or the previous event, and then independent events are it doesn't matter what happens in the first one because you still have the same amount of possibilities. There was no reduction in them for the second and subsequent events that you have. So let's review what experimental probability is. It's what actually happens when you're conducting experiments, and theoretical is what should happen. It is on a simulation or an experiment. Probability is based on what you actually collected from the data. And to figure that out, you get the number of times that the outcome that you wanted or that you were checking for turned out over the total number of trials in the experiment. So if you refer back to your notes from 3, you'll get these. These were the steps. When you have them, you multiply the probability of the first event times the probability of the second to get the total probability, and then you need to reduce it. So we're going to go to the back side. I did an experiment here using the links that are provided in the topic 16 folder on Schoology, the dice roll and the coin flipping. And each time I did that, I did the number that I rolled first and then what I got on the coin second. So 5T means I got a 5 on my first roll and then a tail on my flip. So there are my 50 different trials. And then what I need to do is answer the questions. So we have what is the theoretical probability of getting a 6 and then a head? So what I want to do on this for my 6, there is 1 6 out of the 6 sides. So my probability of 6-H equals 1/6. I'm going to multiply that by and then I'm going to multiply that by the probability of getting a head, which is 1/2. When I multiply that, 1 times 1 is 1, and 6 times 2 is 12. So the probability of getting that theoretically is 1 out of 12. And then if I want to see what the percentage is of that, I would do 1 divided by 12, and then multiply that by 100, and I get 8.3%. Now let's see what we got actually in the experiment. And to do that, I need to identify all of those, and I'm going to put a red dot by those. Nope, I don't want that. Why did that come up there? Delete that. Okay, draw. Okay, 6H. So I have 1 right there. Got another one. And so I got 2. So I have 2 6s. Probability of 6H in my experiment equals 2 out of 50. And that would be reduced to 1/25. And my percent was 4%. Now, theoretical probability of getting a 4 or higher, so greater than or equal to 4. And then tail. So 4, 5, and 6 is the probability of that, which is 1/2. I'm going to multiply that by the probability of getting tail, which is also 1/2. So 1/2 times 1/2 is 1/4. And when I divide 1 by 4, multiply by 100, I get 25%. Now we need to go back and check in our experiment which ones fall in that area. And I'm going to change my color to blue. So we got 1 there, 1 there. So I'm looking for 4T, 5T, or 6T. And almost done. So let me double check, make sure I got them all marked. That's why it's good to have an organized chart here. So I'm going to count my blue marks. I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sure, 10. Oh, there's another one. 1, 2, 3, 4, 5, 6. Oh, 7, 8, 9, 10, and 11. So I got my probability of, let me change that to red, or actually blue. Nope, I'll just keep it at red. Probability of greater than or equal to 4 and a tail. And I counted 11 out of 50. I can't reduce that, so that would be in those terms. And then when I divide 11 by 50 and multiply by 100, I get 22%. Look at the answers for the first one. The first one, our experiment got less than what was anticipated. It was supposed to be 8%, and we got 4%. And then on the with the greater than 4 and a tail, I got 25% theoretically, and I got 22% actual. So that was very close for the expected result. And then if we continued this process for another 50, our scores would probably get even closer to the actual. And if we did it 1,000 times, it should definitely be very close to the theoretical probability of both. So in the practice one, we have an experiment for you to do. You can use those links to do the experiments, and then also there is an exit ticket to go along with it. So have fun doing the experiment, and if you have any questions, come and ask your teachers.